head into example 2. We are going to graph 3 of the cosine graphs. And before we do that, I am going to, as just kind of a reference, we're going to graph the parent function of cosine. So down here below, we'll just review what the parent function is, and then we're going to start to see how the phase shift affects that. And then also we have a k value thrown in there, and then another phase shift happening over here. But before we graph those, let's just review the parent function of cosine. So let's zoom in on that one. So down here, we're going to graph it up to 2 pi. And halfway between 0 and 2 pi would be pi. Halfway between pi and 0 is going to be 1/2 pi, or we call it pi over 2. So this would be pi over 2, 2 pi over 2. That leaves us right here. This is going to be 3 pi over 2. So those intervals represent the right side of our unit circle, top of our unit circle, left side, and then the bottom of our unit circle, and then one complete lap brings us back to 2 pi. So back to the cosine function. Whoop, need the amplitude. We're just going from 1 to -1. And this is y equals cosine. I'll call it x. You could also have it theta. All right. So cosine graph, when you are at 0 radians, your cosine is 1. That's your x-coordinate at that position. At pi over 2, which is the top of your circle, your x-coordinate is 0. When you go all the way to the left side of your circle, your x-coordinate is -1 over there. That's where pi is. 3 pi over 2 radians is the bottom of your unit circle. That would have an x-coordinate of 0. And finishing up your x-coordinate all the way around the circle at 2 pi would be back to 1. And then we can graph our curve, which is going to look something like so. So those are your basic cosine of x and your 5 basic points that we practiced graphing back when we were looking at the cosine graph. Now heading up to problem 2, we're going to start to see the h value, k value start to be implemented into these problems. And then we'll refer back to this example as well. So heading to problem A, we have y equals cosine x plus 3 is in parentheses. That plus 3 means that I have an h value in this case of -3, which means my graph is going to do a phase shift of 3 units to the left. So just a quick visual on that. That means that this point is going to move 3 to the left. This point is going to move 3 to the left. This point is going to move 3 to the left. This point is going to move 3 to the left, and then this point moves 3 to the left. And then I'm going to have another picture of a cosine happening after I do all that. Now we are in terms of pi on our x-axis, so this is 2 pi, and just for reference sake, just keep in mind 2 pi is about 6.28. Pi is about 3.14. So that's just a way that we can think of pi as numbers rather than in terms of that pi there. So heading back to our problem above, our intervals will set up. There's 2 pi. Here's pi. Here's pi over 2. And 3 pi over 2. So if I'm shifting to the left, when I'm shifting to the left, I'm going to take this point that was in my original parent function. It's at 6.28. I'm going to shift it 3 units to the left, which is going to bring me just a little bit more. Remember, this is pi, 3.14. It's just going to be a little bit more than pi. So I'm going to shift that first point to the left 3 units. Then we'll take this point, shift it 3 units to the left. Then we'll take it this point, shift it 3 units to the left, so on and so forth. And then we'll start to make that new cosine graph. For these, they're not going to be exact. You're just going to kind of estimate. So looking at that first point then, let's get a different color. We'll go blue. So 6.28 then is going to shift 3 to the left, which is going to bring me, so this point right here is going to shift 3 to the left, is going to bring me right in here. So there's going to be my first point. This 3 pi over 2 is going to shift 3 to the left. Pi, which is 3.14, that's going to shift 3 to the left. So remember at pi, it was down here, so we're going to shift that 3 to the left, which is going to be about right here. So here's kind of the start of my graph, shifted 3 to the left. And then we know that it's going to end up coming back to 0, and then it's going to finish now at the minimum. So there would be my cosine graph, shifted 3 units to the left. So this point was the point that was at 2 pi. This point was the point that was at 3 pi over 2. And again, I'm just estimating this was the point that was at pi, and then I shifted it 3 to the left. So for number 2a, each point was shifted 3 to the left. Back to number 2, part B, cosine x plus 3. This means that I have a k value plus 3, so I'm going to shift this one up 3. So that means that on my y-axis, I'm going to have to start adjusting for that. So to make sure that I can fit, it has an amplitude of 1, so it's going to go up to 4 would be its highest point, because remember it shifted up 3. And then 3 is going to be where it shifts. And then I could make a 2, and then a 1. And then I'd have -1 all the way down to -4. So if I wanted to keep that y-axis consistent. Now on my theta axis, there's 2 pi. Go halfway in between, there's going to be pi. Pi over 2. And 3 pi over 2. And we'll switch to blue again to show the cosine curve. So the cosine curve always starts at the maximum. So it's going to start at 1. It goes to pi over 2 is 0. Then down to pi, then to 3 pi over 2. Now this axis that I have right here, this is shifted up 3 because of that k value being 3. So what I'm going to do is I'm just going to think of this 3 up here. This is like my new x-axis. So I'm just going to draw a dashed line through here. So there's where my new x-axis lies, and then I can start to graph my cosine. So at 0, my cosine is at the maximum. At pi over 2, I'd be at 0, which now is shifted up 3. At pi, I'd be at the minimum. At 3 pi over 2, I'd be at 0, which is 3 because I'm shifted up. And then at 2 pi, I'd be back to the maximum, excuse me. So then there would be my cosine graph. So same shape as down here. Every point got shifted up 3. So there would be my new picture. And lastly, I've got an x minus pi phase shift. So we'll graph our 2 pi, pi over 2, and 3 pi over 2. Okay, and then this is our h value is equal to pi. So this means I'm shifting each point to the right pi units. So heading back to look at our parent function, that means this point right here is going to shift pi units to the right. This point right here is going to shift pi units to the right. This point right here is going to shift pi units to the right. So I'm going to start looking at what happens when I do that. So my parent function would have a point that's right here. This point now shifts pi units to the right. It's going to start right there. The parent function had a point at pi over 2, 0. That's going to shift just pi, which brings me to right here. Oops, I wanted to make this blue. That's going to make this right there. And I had a point at the minimum where pi is. I'm just using those points from my parent function, and that's going to shift to the right there. So there's kind of the back end of my curve. And if I keep following that periodic, I'm going to have a point right here, and then a point right here. So those 2 points are points that were in the negative x-axis that now get shifted to the right. So there's points like back here that get shifted in. a point back here, that's going to get shifted in to kind of follow that same periodic curve. So each point gets shifted pi units to the right, and all you're going to see then is a negative cosine. So this is what's called a trig identity, that y equals cosine x minus pi is the exact same as the graph negative cosine x, because I'm just starting at the minimum and then I'm going up to the maximum. It's just a basic reflection of the cosine graph. So as you get into pre-calc and higher math classes, you will talk about what are called trigonometry identities, and this is one of them. Cosine x minus pi is the exact same graph as the negative cosine of x. So those two are interchangeable. They mean the same thing. They can be substituted for each other in different calculations, so on and so forth. So there's number 2, graphing, and now we'll head into number 3.